If A and B are any two elements of a group G comma star, then A star B whole inverse equal to B inverse star A inverse. This is known as reversal law for inverses. Consider A star B star B inverse star A inverse, which is equal to A star B star B inverse star A inverse by using associative law. So observe, associative law is A star B star C equal to A star B star C. Consider this as C, then A star B star C equal to A star B star C. Again use associative law, then we are going to get A star B inverse star A inverse. Here also we are applying associative law. B star B inverse star A inverse, which is equal to A star B inverse is E A inverse. We know this is by inverse law. We know that element star inverse of element equal to E. A star E star A inverse is A inverse. This is by identity law. That is E star any element equal to any element. If we multiply any element with identity element, we are getting any element only. Again, by using inverse law, A star A inverse is E. So, we get A star B inverse star A inverse equal to E. Take this as equation 1. This is LHS, this is RHS of equation 1. In the similar manner, B inverse star A inverse star A star B equal to B inverse star A inverse star A star B. Here also I am using associative law. Again, by using associative law, B star A inverse star A star B equal to B inverse star A is E star B. Again, E star B is B. B inverse star B equal to E. Take this as LHS and this is RHS of equation number 2. So from 1 and 2, we get A star B inverse star A inverse equal to B inverse star A inverse star A star B equal to E. From this we can easily say that B inverse star A inverse is the inverse of A star B. This can be written as A star B whole inverse equal to B inverse star A inverse. Once you observe this step, A, consider this as A, this as B, this as A in star B equal to E. So we can say that B is the inverse of A. Take this as B, this as A. Two elements are multiplying, identity element is coming means B is the inverse of A. So therefore A star B whole inverse equal to B inverse star A inverse. In the case group is abelian, A star B whole inverse equal to B inverse star A inverse, which is equal to abelian means AB equal to BA. We can change the order of these elements. in general, A star B star C star K whole inverse equal to K inverse from back side to front. K inverse, C inverse, B inverse, A inverse. In between put star. Next one, left and right cancellation laws. If A, B, C are any three elements of a group G, star, then A star B equal to A star C implies B equal to C. Left side elements are going to cancel. Therefore, it is left cancellation law. Right cancellation law, A star B equal to C star B implies A equal to C. Right side B is going to cancel. That's why this is right cancellation law. Observe the proof. We are taking LHS. We want to prove RHS. Consider A star B equal to A star C. Multiply both sides with A inverse. A star A inverse star A star B equal to A inverse star A star C. Again by using associative law, A inverse star A star B equal to A inverse star A star C. We know that element star inverse of that element is equal to E. Apply here also. This is also E. E star B equal to B. E star C equal to C. Therefore, by considering this, we proved B equal to C. Therefore, left cancellation law is proved. In the similar manner, we are going to prove right cancellation law. Consider A star B equal to C star B. Multiply both sides, right side, with B inverse. C star B star B inverse. Again use associative law. A star B inverse equal to C star B inverse. Now by using inverse law, B star B inverse equal to E, C star B inverse equal to E. A star E equal to A, C star E equal to C. So, by considering A star B equal to C star B, we get A equal to C. So, right cancellation law is also proved. Next property, if A and B are any two elements of a group G, star, then the equations A star x equal to B and Y star A equal to B have unique solutions in G. So, case 1. We need to prove this theorem now in two cases. First one is case 1. So, observe what is the given conditions. A and B are any two elements of G, star. Satisfying the equations A star x equal to B and Y star A equal to B have unique solutions. We want to prove that these two equations will have unique solutions. Case 1. Since each element in a group G has unique inverse, that means if A belongs to G, A inverse exists and that is also an element of G. Now, A inverse belongs to G, B also an element of G. If two elements belongs to G, then by using closure law, A inverse B belongs to G. Now substituting A inverse star B for x in the left hand side of the equation A star x equal to B. So we are substituting this value as a x. So A star x equal to B becomes A star A inverse star B which is equal to A star. Again use associative law. A star A inverse star B. We know the value of A star A inverse, that is E star B equal to B. So this is the RHS. That means if we take X as A inverse star B, then this equation is satisfied. Whenever this equation satisfies by taking X equal to A inverse star B, then this is the solution for this equation. Thus, X equal to A inverse star B satisfies the equation A star X equal to B. Also, A inverse star B is also an element of G. Therefore, X equal to A inverse star B is a solution of A star X equal to B in G. Now, we want to show that this solution is unique. For that, we are taking X equal to X1, X equal to X2, B, two solutions of the equation A star X equal to B in G. That solution means that solution must satisfy this equation. Here X equal to X1 is solution. That means if we replace X with X1, then we are going to get B only. In the similar way, replace X with X2, then also we get B only. So observe here RHS are equal, so LHS are equal. That means A star X1 equal to A star X2. Now use left cancellation law, then we are going to get X1 equal to X2. That means we considered X1 is solution, X2 is also solution. Now we proved these solutions are not different, those two are equal. Therefore, A star X equal to B has unique solution in G. In case 2, we are taking Y star B A equal to B. Here multiply with A inverse right side, then we are going to get Y star A inverse equal to B star A inverse. Use associative law. Y star A inverse equal to B star A inverse. So Y star A inverse is nothing but E, B star A inverse. Again we know that Y star E equal to Y, so Y equal to B star A inverse. So Y equal to B star A inverse is the solution of Y star A equal to B. Here also we are considering there exist two solutions. Y1 is the solution, Y2 also solution for Y star A equal to B. Solution means it must satisfy equation. So replace Y with Y1, Y1 star A equal to B and Y2 star A equal to B. Here also RHS are equal, so LHS are equal. So by using right cancellation law, Y1 equal to Y2. So here we taken two different solutions. Y1 is solution for this equation. Y2 is also solution for this equation. At the end, we proved that these two solutions are equal. That means the solution for Y star A equal to B is unique, and that solution is Y equal to B star A inverse.